Come on up, Mike. So finally we have Mike Crimmins who's going to talk about probably rangeland stuff, something to do with droughts.
I hope so. Good morning, everybody. I have to be honest, I'm feeling a little inadequate because I don't have a single tree ring in my study, and my 62-year time period seems very sad now that I'm looking at all these wonderful hundreds of years chronologies. So I've used, there should be another slide there. Great. I've used this slide the last couple of CLIMAS talks I've got, and this is kind of a talk of a trajectory of thinking that I've used in my position. I'm an extension specialist, and so I do applied research and extension. I work on the Governor's Drought Task Force. I work with land managers and resource managers and farmers and ranchers across the Southwest. And so as a climatologist in this sort of applied realm, my job is to try to help tell good drought stories, right? Is to try to actually track what's going on. And we're doing this across a very interesting, unique landscape with a lot of variability and a lot of really unique climatological aspects that make it really tricky to tell a good drought story. And then to not only tell a good drought story, but actually to track drought in real time. So we may end up having some questions afterwards. Well, how are we doing right now? Not great, but I've had discussions with other people say it's not as bad or it's much worse. And so this is the real challenge when we're talking about across the region that has a real strong seasonality and precipitation. You're coming and going with different really types of water from winter to summer and the way that plants are seeing it with punctuated short climatologically extreme seasons, topoclimatic variability, having ecosystems at the top of mountains and the bottom of mountains that are fundamentally different and using water fundamentally differently in different seasons, hitting the guardrails from year to year with interannual variability, and then increasing temperatures. So it's kind of getting all of these aspects together, and that's who you are, what you're worried about, and some even more unique aspects of from down to a plant species level of what are we talking about? We're talking about drought. So it's tricky. So the stuff that I try to work on here is to try to help tell a good drought story depending on who you are and where you're at and what you're actually worried about. And I've really, and my job focused on the land management, ecosystem, farming, ranching side, because there's so much good stuff going on with water. I've tried to kind of stay away from it and kind of go down to this sub-seasonal, seasonal, maybe series of seasons over a period of years when we're talking about drought. And then on the other side, so this is the CLIMAS aspect that Dan and I have been working on is what are we actually trying to inform when we're talking about drought monitoring or using these drought indexes. And there's a new project that we've got going on in this current funding realm of CLIMAS that we're going to really try to dig in on this. And then another thing is that I want to make a new index. I really, really do, because it's cool, and that's what climatologists do. But can we point back to the existing resources we have and use those better instead of making something new? Sometimes you need something new. Sometimes something old in the closet will work just fine. And then figuring out how to actually do that. So one of the projects that was really informative to me, this was something that Dan and I worked on for a long time, starting in 2010, I believe. 2009 was our sort of first on the ground working with Hopi DNR and then Navajo Water Management Branch, is just getting up on the ground and then helping them think through drought impacts that they've observed over the recent past and then putting them into a larger context, and then helping them think about how to implement any sort of management or planning that would be useful for the region. And so it's very place-based science. And as Chris talked about in his research, and Connie kind of alluded to in the broader watershed, it has all these unique climatological aspects: strong seasonality, topoclimatic variability, and then fundamental and unique management objectives of the landscape. So we did a lot of just sort of on the ground talking to folks. This is a really cool exercise that Allison led us through with this. It looks like a Trivial Pursuit pie piece sort of thing.
You just dated yourself.
I know, and that's the only thing I think of when I see this. But those are all months, and we use that as a decision calendar to have a discussion about what those concerns were. And so in that discussion, fairly obvious to them, but not as obvious to me, was, okay, so it's really about some very fundamental shifts in the timing of precipitation. It's the background temperature, it's the seasonality between winter and summer, and it's the management timing and the management actions that are occurring at different times of the year that are really important. And that's obvious if you're a manager. If you're trying to do a climate index, sometimes you're just going to drop something on somebody that's annual and it won't quite get to the nuances here. And so this got us thinking about, well, how can we tell a good drought story, get into the data, and then tell a drought story that is actually meaningful to some of these particular things that they're worried about. So I translated the Trivial Pursuit pie pieces onto this climatological, and this is where we took station data, daily station data from a series of co-op weather stations across the Four Corners region, and then just transferred it into some timing of the decision calendar, and then what the background climatology of daily cumulative precipitation looks like. And so it's got the seasonality that we talk about, but it's an interesting sort of slow approach and then strong approach here, and then these bands of variability around it show you that we're dealing with sort of epically variable climate here, which we know that as far as Arizona. So how do you take timing issues and then sort of drag out unique climatological variability in the historical record to examine drought variability? So what we did is we, again, went back to those data sets and then really started to think about, I think, this concept of effective precipitation, which is an old thing in literature, very vague and kind of ambiguous. And so the rest of the talk is to try to really get at this, but it's having the right amount of precip for the right thing at the right time, right? And then in a highly variable climate where we have this programmed in dry spell, we have a climatological drought just in our back pocket, is that timing and the amount becomes very, very critical. And sometimes when you're just doing a retrospective, when we even go back, we think in our heads, what was last year's drought looks like, we will forget, right? We will have it erased by that one great event and think everything's back to normal. And sometimes when we'll look at a drought index, that drought index will pop back to average and it will hide some of the things that are in the historical record. And so kind of on what Connie was looking at with some of these different flavors, we tried to sort of draw out, are there sub-seasonal flavors of drought in the historical record? So what we did here is this is sort of that traditional, again, from that Four Corners series of co-op stations standardized up to a regional signal, and then just plotted as you kind of typically look backwards at annual precipitation. And you see, I think, a lot what everybody else was presenting, which is sort of the pluvial here, some variability in the 90s, the 2000 to 2003 drought period. Here is the 50s drought that a lot of us have focused on. And so this is the sort of the traditional way. And what we did is we went into the data set and calculated about 30 hydroclimatic extreme indices that the World Meteorological Organization standardized. They're using it for sort of climate change extreme projections. We went back in the historical record and said, can we use these in a practical way to look back at droughts, and then looked for the ones that had unique variability relative to the total precipitation that would add to the discussion, add to the variability. Okay, so it's principal components, analysis, reduction. So these are correlated with total precip, but they're slightly different. So they have an uncorrelated aspect to them in their temporal record. So you get things like max 1 day total precipitation sometimes is related to an above average year, but sometimes isn't, right? So did you get a lot of your annual precip in one event? This to me, I think, is really interesting looking backwards at the end of a year. Was it more winter, more summer, right? And then that has really important implications from a management and an ecosystem perspective. The ratio of the total amount of precip to the number of days that you're seeing within a given year. So where the days was most of the precip coming on 1 day versus a series of days from the total, the dry spell length, and then the max 5 day total precip event. So this helps us then sort of drag out and look for a signal that's not just in the total precipitation signal. And you get things like this, where if you go back to those 2 4-year period droughts, this was in Dave Brashear's global change, the PNAS global change type drought study. And in a lot of other studies is comparing sort of this contemporary drought to the 50s drought here. And then looking at those in particular, what are some of the unique aspects of them? This was certainly a warmer drought than this one was a cooler drought, but it had some really different things occurring within the year. So this was in 2002, which ended up having a much drier winter and some sort of typical increase in precipitation here in the summertime. And then most of the annual total occurred in September, which is interesting because it's the end of the growing season and it was a high runoff event. So it contributes to the annual total and kind of is maybe not as effective when we think of effective precipitation. Whereas 1956 was certainly a cooler drought, but ended up having a lot of little events all the way through the spring, and then into the summer, and then the summer was a bit drier, and then into the fall, and then actually had some late fall events. So hydrologically and hydroclimatologically, these were different, even though they were different temperatures. So I think that's another aspect of drought that we need to think about as far as the extremeness of the subseasonal variability in a given year. One thing that showed up in this is that if you just go back and look at the annual totals, 1972 was a very wet year, and to me was not a drought year at all by any means, right? But this was interesting. We started to plot these and look at our extreme indices. And also the extreme indices pointed to 1972 as not being normal. It was a wet year, and so you think in your head a wet year must be a really great winter, a really great summer. Well, actually it was much, much drier in the winter time and had some oddly timed June precip, had a fairly normal monsoon, and then got well over half of its annual total in about a week in late September and October, and then ends up pushing 1972 to be one of the wettest years on record looking backwards, but hydroclimatologically was one of the most extreme. And so, again, I think you'd know that in a given year as you're going through it, but when you look backwards and try to tell that drought story is sort of masked in the data set. Okay, so this is just another axis of variability that I'm trying to think about, and how do we actually do this operationally? And I'm not totally sure yet. So this is total precipitation, all of those years in our period of record in this direction. The colors then are if they're warm or cool relative to this historical record. So wet years up here, so we have wet, cool years, we have wet, warm years. The bottom here, we have warm, dry years, and we have cool, dry years. Okay, so that's that variability that we were kind of talking about in the previous talks here. This is another aspect where we took those 5 indices and collapsed them down into hydroclimatic extremes index. I got my index. I made an index in here at one point. Is that you get to these kinds of events here where they're dry and they're warm, but they're also extreme in the way that the precipitation is coming into the system. So I guess I would argue is that under warmer, drier, and more extremes, you have even less effective precipitation when we're thinking about it, say from an ecosystem or from a management standpoint. And you have some of these situations where it's wet, but it is also extreme. So is that a way to actually go back and look at a quote unquote wet year and say, there are probably drought aspects that are emerging just in the effectiveness of the precipitation. Okay, so this kind of index is not particularly practical in an operational standpoint. It's retrospective, and I think it's useful in telling a drought story retrospectively, maybe going back and looking at some management data or some impact data to try to tease these out. But I really now am moving towards how do we take this full circle to an operational standpoint? And so it's this effective precipitation is really what's behind this thing right here is soil moisture. Okay, so how do we now think about effective precipitation and really think about it in terms of soil moisture? So this is a project that, another CLIMAS project that was funded out of the same NOAA drought work and is now part of a new CLIMAS project that a grad student I'm working with, Trevor McKellar, on is where we're taking a soil moisture model with the same daily data, modeling soil moisture, looking at some of these extreme indices and seeing how they actually fit together. And then do any of our drought indices at certain time scales and at certain windows pretty well replicate what we're seeing there. So it's a way of sort of funneling down and winnowing out the best drought indices that are capturing some of the unique variability. So we can do things like look at Tucson's strong seasonality. You see strong wet signal in the winter, the dry arid forest summer, and then the summer here. We create these daily indices. We can convert them back into a standardized drought index, and then do things like this where we correlate them back against existing drought indices. This is standardized precipitation index, standardized precipitation minus evapotranspiration index. So this is temperature and precip, just temperature. And some of our early results here is that the 2-month SPI tracks shallow soil moisture reasonably well at about a 0.8 correlation and just beats out SPEI just slightly. And I'm not sure why yet. Why at the short time scales, the SPI just edges out SPI. Maybe it's not distinguishably different from each other, but the added temperature variability at that short time scale doesn't seem to correlate any better. And so I think it's at longer time scales, the temperature aspect really shows up in the water balance, but at the very short, the timing of the precip is most important in controlling soil water status. We also know too is that at about 30 centimeters, it gets much, much harder to track soil moisture variability. If you've ever looked at a soil moisture time series at that basis, it's a mess of coming and going based on wetting fronts coming through and what plants are there to draw out the soil moisture. So it's much, much trickier to use these drought indices for deeper soil amounts. And then just real quickly, just some of these results here too, is that this is the time series for Tucson from 2000 to 2015. You can see they track each other very well, but there's this residual here between the SPI and the SPEI versus that comparative soil moisture index. And we get these situations where they're bobbing around, they're within one standard deviation unit, and every once in a while you get this large departure. And this one in particular caught my eye, which we're sort of poking at a little bit more. And this was 2005, 2006, which is interesting because the current conditions are very similar to 2005, 2006. We're talking about water year precipitation. And it was a very, very dry fall and winter season. And we had a little bit spit of March precipitation. The drought indices at the short time scales got excited about it and went hooray, and they improved. And then the soil moisture time series said, forget it. That was useless precip. This is probably where the aspect of the poorly timed and also background temperatures of that particular spring just dragged soil moisture down. And so that was an interesting departure, is that when are we getting to situations where our drought indices are telling us one thing, but the landscape and what the plants are seeing something different. And this is really where I want to get as we go forward. So the final thoughts is that all of this research, in my mind, what I'm trying to do is move some of the research that like Connie and Chris are working on, and then try to take some of the results of that and take some of the stuff I'm working with here. And then how can we take what we're learning from that and then focus it on specific management needs in specific areas. I think we have a line on the current analysis, which is thinking about using something like the standardized precipitation index differently each month and where you are at the different parts of the state. So you're able to consult the right information at the right time for the right thing that you're trying to do. And so this idea of a drought monitoring playbook is something we're playing with. This I really want to push on too is that in the analysis that I'm using is that we're using these estimates of evapotranspiration, Penman, Hargreaves, Thornthwaite, and I'm not sure which ones work best. I have an idea, and how they're actually getting integrated in the drought indices and what they're actually doing to the drought indices, I'm not sure if they're working quite the way that we think they are down here. And so I'm hoping that we'll be able to tease that out a little bit more in some of the upcoming research that we're working on. So thanks.
Thanks, Mike. All right, quick question for Mike before we get the whole crew up here. Okay, so Connie and Chris, could you guys rejoin us? And Ben, can you make the camera so pointed? Yeah. So it's just on them? So what I had in mind here,